Good morning, and I'm sorry I have to speak English, but I can speak a little bit Danish, but it's difficult to make a presentation here. Okay, as you see, the topic of my presentation is about plant hormonal and the growth response to soil compaction. And first thing you may ask, what is soil compaction? Soil compaction has been defined as a reduction of soil porosity and induced by any human activities applying a mechanical stress on the soil, and which can modify soil properties and lead to the deterioration of one or more soil functions. And below the picture illustrates clearly about what's the compact soil and what is the non-compact soil. You can see, compared with the non-compact soil, the compact soil has less air space and water content in the soil. And what the causes for soil compaction? There are two kinds of main causes can cause soil compaction. The first one is naturally induced soil compaction, especially when soil has higher clay content above, for example, 35%. We have high soil moisture, and this soil is easy to be compacted or susceptible to compaction. And mostly, actually, the soil compaction being caused by human activities. For example, the inappropriate tillage, you have very heavy machinery go to the field more frequently, and you use very shallow root crops for many years. That means an inappropriate soil rotation system, and also you have low amount of organic residues in soil. That's low organic matter content in soil can also easy to cause soil compaction. And if we look at Europe and what kind of soils or which areas are susceptible to soil compaction, and here if we see in Denmark, and we have this around pink to orange colored area. Actually, it's located just in the, I think around this area, in the middle of Jutland. The soil has a little bit higher clay content, and then that's susceptible to soil compaction due to heavy machinery operations in the field. And the depth of soil compaction or the severity of the soil compaction can be induced by increase of the machinery load. For example, when you increased the weight load of your machinery, and then you have more deeper impact of your soil. The compact soil become deeper. And if you have the same machinery load or the weight of the machinery go to the field, and then you have, when the soil moisture increase, you also can increase the depth of the soil being affected to be compacted. So both factors, the machinery load and also the soil moisture, closely relate to the depth of the soil being compacted. And what's the impact of this soil compaction? And this picture shows very clearly about if you compare the non-compact soil and the compact soil. And for the non-compact soil, you can see have very better root development and deeper root system, and the plants, the shoot grows properly, normally and function well. And in the compact soil, when you have a very hard compact layer or the pan below the root system, the root cannot penetrate this root zone, and they have very shallow root system, and so the water cannot also penetrate this system, cannot penetrate this area, and those, so they can forming surface water easy to have runoff if you have heavy rain afterwards. And also the root grows very shallow, and the nutrients uptake also being limited, so the plants grow not well as the non-compact soil. And if you look at in the field and the field conditions, and here I show the three kind of treatment on the top is non-compact soil, and the plants grow normally, and you can see appearance much better than below. This has a moderate compaction treatment, and below the severe compaction treatment, you only have very few seedlings appeared. That means during very early stage, when the seeds germinate and the established seedlings already affected by soil compaction. And in the field, even though the plants already established, so you can see the well tracks, and they accumulate a lot of water when the soil is compacted, because the water cannot really go down or reach down to the deeper soil layers, and can induce soil and water erosion. Also nutrients may be ran off and to the surface water. So that may have a risk of pollution of the waters. And from a personal communication with Dr. Valley from UK, and he forwarded these slides to me, and he analyzed the relationship. Here shows the dry matter production for winter wheat and related to mean petri-meter resistance of the soil compaction degrees. I would like to see that. And you can see when the soil becomes more compact, the dry matter production actually decreases linearly. So that gives direct illustration about how compaction of soil will affect the dry matter production of the plant growth. And for many years, for these soil compaction studies, and people try to see what the first response of the roots to the increase of the soil strength. And early studies show that. I took this picture from literature and Salter, published in year 2001. And here include different stress factors: soil drying and the increase of soil pH, and the salinity increase in the soil, and also includes soil compaction. So increase of soil compaction, actually the roots will sense this change of the mechanical stress around the root system. The roots can produce the abscisic acid, AB, signaling accumulate to a high level in the roots and being transported into the xylem system, which can follow the transpiration flux and go up to the shoots and to the leaves that can induce stomata closure that will decrease the stomata conductance and decrease the transpiration rate of the plants. And of course, this will affect many other plant metabolism processes and also the plant physiological processes. Finally, will affect the yield and the plant growth. So this means, from this picture, I just want to indicate it. The impaction of soil involved these hormonal changes in the plants at a very early stage. And here shows a result from formal study, and compare the plants, winter wheat plants respond to soil drying in the compact soil and the non-compact soil. You can see in the non-compact soil, the response to soil drying with the leaf expansion growth decrease not so severely as in the compact soil. That means at the same level of water stress, the compact soil actually added more stress, and the additional factors affect leaf expansion growth. So the scientists try to explain what happened during this kind of stress treatment. Here I shows maybe it's a little bit smaller figure here. It's difficult to see it from the end of the audience. But here shows the direct evidence of this abscisic acid signaling in the regulation of stomata conductance in barley growing in compact soil. So they have treatment here, shows 4 treatment, different treatment. We have the uniform 1.4 gram per cubic centimeter treatment, and this normal non-compact, and we have 1.7 gram per cubic centimeter soil, this compact soil. We have two cultivars here used. So this, you can see the two cultivars respond differently. Here is the stormwater conductance. One of the cultivars in the compact soil decreased stormwater conductance very clearly. That's correlated very well to the increase of xylem sap AB concentration in this cultivar and in the compact soil. And another treatment is that in the surface soil we have 1.4. It's not compact, but in the lower layer of the soil we have the compact soil. For the second cultivar, we can see that. And when the soil at a non-compact surface soil, the stormwater conductance is higher. But once the root meet the compact soil, and the stormwater conductance dramatically decreased. So this corresponding to a dramatic increase of AB concentration. I don't want to explain the other treatment here, but from these two treatments, we can already get an idea about when the roots meet compact soil, the reduce of stormwater conductance is correlated well with the increase of xylem AB concentration. So that's indicated high AB concentration under compact soil involved in the response of the plants to the stress. And we have an experiment set up in Jordpakning, and here in the field plot we have 4 treatment. We have 1 is 0-10 treatment, 2 is 3-10 treatment. We have machinery, this lot of the machinery, and the third one is 6-10 treatment, and fourth is 8-10 treatment, but only treated in year 2010. So we have 4 blocks, and each treatment 4 replications. And this results from last year, year 2012. And we measure this RVI, this index, and that's the indication of the leaf area index. And we also measure plant height. We can see that in the control and also in the 8-10 treatment only did in 2010, we have the highest leaf area in the end, almost in the middle and in the end of the season. And the 6-10 treatment for 3 years, this started from year 2010, and this has significantly less leaf area compared with the 0-10 treatment. And correspondingly, we found also the plant height had the same trend of change. So that means this soil compact affected plant growth clearly. And however, we may also collect the leaf samples to measure the leaf AB concentration, and we also measure stormwater conductance of the plants, of the leaves. And we found that there's very big fluctuation of the leaf AB concentration during the season, and there's no really clear trend of change according to the different treatment. And similarly for the stormwater conductance. And I would like to highlight that the measurements has been done in the plants and one day, doing 1 time per day and at different days. It's very difficult to catch all the changes during the day, diurnal changes, and also the whole seasonal fluctuation of the treatment. And further, in the future, we should measure, for example, try to collect the xylem AB concentration, and in that way, maybe we can have a clear picture about how this treatment will affect this AB production in the plants. And the last slide I would like to show you, even though we cannot see this biochemical or the AB concentration changes, and also stormwater conductance has changes related to the treatment, but still we can see the impact of the different treatment on the grain yield. And from 0-10s, we have around 72 tons per hectare yield, and 3-10s reduce around 5 tons, and at 6-10s even reduce more, and 8-10s treated in year 2001 has no impact from year 2012 and has a similar yield as the control treatment. So I think this is the last slide, and thank you for your attention, and questions may be asked later on. Thank you.
Ja, tak til dig,